Hello guys, I'm Mangaseni and today we are going to discuss about hashing. So uh, let's start. This is contents which we are going to cover. First of all, we'll discuss introduction, what is hashing, and we will after that we will see basic structure and basic terms which is used in it, and after that we will see hashing function, then working standard this and after that we will proceed in this lecture on the remaining topics. So let's start by introduction. It's one of the important technique to implement dictionary. And why it is used and why it is too popular, because it's provided a constant time per operation like insertion and find means search, and it's in average time. In average time big O it's big O of order constant, so it's provide constant time in relation and find. So it's not guarantee that it's always a constant time, but in worst case there may be order n, which we will discuss that how this type of thing arrive. It's used to index and retrieve item in a database and assign a key value to an index of an array using hash function. So we will see this thing when we will discuss about hash function. It become easy and faster to find the item using the shorter hashed key. So this is nothing but nothing. This is only the index which we are going to assign at the time of hash table. What is hash table? So it's a data structure, store data in an associative way, which is an array format. So uh, each data value has its unique uh, index value, which is generated through hash function. And after that, access of data becomes fast if we know the index of the desired data. Let's suppose you want to search something, and so you don't have to, if you know that where is it, then it become very easy to just capture that data. So there is a similar idea in it. It's just assigned by the hash function. We assign a particular value which is known as hash key, and hashed key, and which is available in hash table. So we directly go at that index and we can retrieve that data and we can find that data. So what is hash function? So used to assign index of original key or value, it must always return a location which is valid in the table. A good hash function should not produce collision. So there is a possibility of collision. We will see about it also in this lecture. So a good function never produce a collision. Choose an hash function in that manner that collision chances are too low. We should always choose a hash function so that it can be decrease the chances of collision. We always try to avoid collision. So how it's work? So let's suppose there is a hash function h and element e, which we have to, which is nothing but is data. So which has a key k, so which is generated through this hash function. So we will see how to generate that particular key. So e is stored at hk position in the table. So this will give us the location of that location or position of e element in that particular table. So to search any element E, we have to just get HK for the location. If no value is there, then it means E is not exist or present in the table. So standard hash function. So there are many type of hash functions. We can also introduce our design or introduce our hash functions. So, but there is a standard hash function, means which is known as division reminder method, which is normally used in a low level. So what is in it? So this is hash function which give this is the hash function which you can see. and this is their hashed value which written after applying the hash function on the key. Key is nothing but its element or data, and this is mode, which is the operator, binary operator, and this is table size. So we just take a mode of key or binary size, which is that's the only hash value. So let's take an example and understand it by an example. So let's suppose table size or partition in tables are 100. So there is this is the key. So 50289. So 50289 more 100. So it's 89. So it means this element will be put on 89th location in the table. Um, so same with this case, 20112. So mod 100 is equal to 12. Mean this data will be put into 12th location, or this data can be found if it is available in the table on 12th location. So let's understand it by more example and in a brief way. So let's suppose there is a student's record. Now there are 100 students which have entry numbers 50, which have last 5 digit entry number 50289 to 50388. So now we can apply this hash function which we have already seen, that division remainder hash function. So we have applied the same hash function here, and we can now find we can allot each bucket. This all known as bucket. So we will also use this term later on. So the box is also called bucket. So each entry number will have a particular bucket in which it have data of its like name, branch, and year, everything. So there is 100 the size of the table is 100, and there is only 100 students, so we can put all students in it. So now if we analyze the above case or above example, we can find that the hash table initialization is order n. We have to just put each data once, so it will take order n. But and for insert, find, and deletion required order 1, which is constant time. So as we can see that, let's suppose I have to find 502229293. So it's 93. I can just find HK, which is 93 for that value, and I can directly go 93. So it's order time, a constant order time. So that is we have talked about it. So what is the flaws in the ideal case? Mean one-to-one matching. So many applications are too large, then or database is too large, so it's required too big hash table to map one-to-one key. Let's understand it by an example. So let's suppose there is some database, or there is some data of 1 lakh in which contain 1 lakh entries. So it become very difficult, which is obviously not a practical manner that you are creating 1 lakh slots in a hash table. So this is not a practical manner. So there are this type of flaws exist in this standard hash function. Uh, so in this type of case, large range use less bucket. So how we have solved it? We use less bucket in this type of case. So like how we solve it? We use hash function with direct multiple key of same bucket, like p1 have also c location, and p2 also have c location. Mean p1 p2 are different elements, but both have c location, c slot or c location. So now this type of thing is called collision, by because p1 also has the same location, p2 also has same location, so it's collision. So hk is equal to k by b, where b is number of bucket. So as we have already seen this method. So as we have already discussed that collision thing, but we can understand it by an example. Let's go through it once it. Let's suppose there is 77. There is a hash function which we already discussed. So 77. If we will module, it will become 7. Same case for 33, there will be 365. For 65 there will be 5, and for 27 it will be 7. So there are two values or two keys which have same slot, 7 and 7. So it is collision. So this type of thing take place. So I hope you got a point from here that how collision take place. So now we will talk about how we can avoid collision, or what is the way or what is the method by which we can just avoid this. So let's talk about that. So there are two techniques which we are going to discuss in this lecture. So first one is the open hashing, and which is also known as separate hashing. So it's separate chaining. And after that, the second method is close hashing, which is also known as open addressing. So let's first we will talk about open hashing, and after that we will talk about close hashing. So open, as we already know, open hashing is also known as separate chaining. So what is in it? And obviously this is technique to avoid collision. We have already discussed about it. This is combined. So what is in it? This combined linked list and hash table. So as we know that linked list and hash table. So this method is just combine linked list and hash table, and in this manner it try to resolve this type of problem. So we store the value or key in the linked list. Instead of storing that in a hash table, we just store that in the linked list. So we will see that how we do that. So the same value returned by the hash function add in the linked list is a sorted manner. So in linked list it will be in sorted manner. Mean if there is values, it will be sorted. So what is the procedure of it? First search slot written by the hash function in the table, and then enter in the linked list which is on that slot. After that, visit the list of search of the key, and you will find it there. So let's understand it by an example. So what is that? Let's suppose we have a hash function of hx is equal to x modulus are 10. So and x is there are 1 2 3, there are 9 values which have 9 x values which we are going to talk about. So in starting, that linked list will be empty. Let's suppose we starting from first element, and we will go through 79, and we will see that how this separate chaining work and how it avoid the collision thing. So for x is equal to 1, hx will hx yani mean h1 will be 1. So it will go in the first slot. So what will happen? So there will be a link that linked list slot, and it will be put into that. So we will see in next slide. Yeah, as you can see that in the last term we have just seen that x element. Now it's added on the first slot. So now let's take another element 20. So for 20, as we know, the modulus of 20 will be 0. So it will go in the 0th location, mean 0th slot. So there is a linked list which where it have stored. So after 31, as we now we can see 20th completed. Now we can see now we will take 31st element. So 31st element is 1. So it will again now you can notice that 1 is already filled. but in a separate in a normal hashing it is filled, so there is chances of collision. But in separate chaining, what happen now, it will also this linked list will evaluate, and this 31st element will add in this linked list in a sorted manner. So we can see like this. So 31st have added in this and the last element is empty. So as we can avoid the collision in the separate chaining, so we will repeat, we will continue this process with the whole elements, and we will see. So now for as we can already seen of 31st, now we will 31, now we will see 34. So 34 there will be 4 remainder, and it will go in fourth slot. So we can see it have in entered or stored in 34th fourth slot. And now after 34th it's 56 for there will be hashed key will be 6, so it will store in sixth slot. So it have stored in sixth slot. Now it will now now it will after 56 it will 96. So for 96 as we can see 96 there will be 6, so it will just attach. There is some kind of problem which we have faced here, so there will it will also attach in the forward in a sorted linked list. So as we can see that it have attached here. Now we have already covered 96. Now let's come on 9. So for 9 there will be 9 remainder, so it will go in ninth slot. So as you can see it have already attached ninth location. Now same we will repeat the same case with 69 79. For 69th there will be 9 remainder, so it will attach in the just with the 9. And the same case will happen with 79, and 9 is the remainder, so it will also go in ninth location. So it will just attach in this linked list, so it is attached. So now the x is the x have finished, and we have already stored all the elements. So in this manner we just using of separate chaining just try to avoid collision. So as we have seen that we have stored all the elements and there is no collision. So by this method or by using this method we can avoid collision. Now we will talk about the second method, which is closed hashing. So this method don't use a linked list which we have seen in previous method, but this method avoid collision by rehashing. So we will see what is the mean of this term rehashing. So what is the procedure of it? So if hx slot, which we also known as a home bucket, so if it's a filled, then we if it is filled, then we will try to implement other hash functions. Mean there is not only one hash function, there is only one hash function which is known as home bucket, but if it is filled we generate other hash functions which is known as h1 h2 h3 and etc, and let's go on. So and we will just keep trying until we didn't get an empty bucket in which we can just put that. So for rehashing, how we compute h1 h2 and so on, so we do it by linear hashing. Okay, so what is linear hashing? There is a linear hix is equal to hx plus I modulus by d. So this is rehashing formula by which we can just compute what is the hash function of h1. So let's understand it by an example. So let's suppose d, which is the size of that block or table. So d is 8 and hx is x modulus 8, and x are 19 40 36 and 51. So let's took 19. So let's took first element 19. So 19, for 19 it will, we can calculate, so it will be 3, so hash key will be 3, so it will store in the third position. So it have stored in the third position. Now for the second element, 40, we can see 40 modulus 8 will be 0, so here is a 0, so it will store at 0's location, so it is stored at 0's location. Now let's come on third element, which is 36. So for 36 there will be 4, so hash key will be 4, so it will store in fourth location or fourth slot. So it have stored at 34 is stored at fourth location. Now fourth element, which is 51. So 51, for 51 hash key is 3. We can compare it by this, which is 3. So now when it will enter at here, but it will find that it's already filled, so mean it's a home bucket is already filled. So now we will apply that close hashing in it. So we will just rehash this 51. So as we can see, slot 3 is not empty, so we will apply rehashing. So h1 51 is equal to h51 plus 1 modulus 8. So we can see we can compare this formula from there. So h, as we have seen that there is a formula of hi x is equal to hx plus I modulus d. So I is equal to 1 here, so we have put just I, and x is equal to 51. So now it's 4. So what is the value of it, hashed value of it? This is 4. So we will see, we will try to put 51 in fourth location, but we will find that 36 already filled at fourth location. So we can see that 34 is already filled, slot 4 is not empty, so we have to do again linear hashing. So now for h2, 51 is equal to h51 plus 2 modulus 8. So now it will just recalculate, and its modulus is 5. So now it will try to enter its fifth location. It will find that fifth location is the empty. So now it can put at the fifth location. So now it can put in the fifth location, because fifth location was empty, so it's stored in the fifth location. So we can also apply this method on more elements, and we can see that by these two methods we can avoid collision. So this is a basic introduction of and basic structure or basic understanding of hashing, that what is hashing and how to implement hashing in data structure or in another manner, and how to avoid collision in hashing, which is a very important part. So thanks for watching.